All right, guys, this is section 2.2, and this is all about how to solve. And solving, remember, is about doing our order of operations kind of in reverse. So when I look at this one, it says I have 3x equals 12. Well, how's that 3 attached to the x? Don't forget that's an implied multiplication. And what's the opposite of multiplication is division. So therefore, I will divide both sides by 3. And then x is equal to 4. You think you're done, but remember, always and forever. I even give a point on the test for this if you check your answer. And you're going, I don't know what I'm doing wrong. I know it's wrong, but I don't know what's wrong. Versus you would lose 2 points if you hadn't even checked and were showing me that you were getting the wrong answer. So how you would check, you take your answer, your 4, and replace it with the x. So you do 3 times 4, and you're going to ask, is that equal to 12? Well, 3 times 4 is 12, which is equal to 12, so that checks. All right, the next problem. What about this? What about that negative? Negative y is equal to 2. How do you get rid of that negative? Well, you can either multiply it by -1 or divide by -1. I usually divide by -1, divide by negative. So that gives me y is equal to -2. Okay, again, we're going to check here. So you have negative, -2, and is that equal to 2? Well, a negative and a negative make a positive, so 2 equals 2. Check. All right. My third problem here. Uh-oh, it's got fractions. Before you freak out, don't sit there and say, I hate fractions, because fractions are your friends. Okay, we want to isolate the x. We want to get x by itself. Well, I've got 2 over 7. So I really want to multiply by what they call the reciprocal, which is the same thing, as what you've got in the x, except this denominator becomes the numerator and the numerator becomes the denominator. And remember, if you do it to one side, you've got to do it to the other side. Okay? So I got 21 over 21, 2 over 2, leaving me x is equal to, oh, those 2's cancel. And now, do 21 and 7 have anything in common? Well, they do. They have 7. How many times does 7 go into 21? 3 times. How many times does 7 go into that? Once. So that would give me 3 over 1, oops, which is equal to 3. And now you're going, oh, no, I've got to do this. I've got to check this. Well, yes, you want to check this. It's not too big. So you got 2 over 21 times 3. Is that equal to 2 over 7? Well, I'm going to make this a fraction. Again, I'm going to look at the crosses. Is 1 and 2 have anything in common? Well, 1, but that doesn't get us rid of anything. This 21 and 3 have something in common? Yes, they have 3's. How many times does 3 go into 3? Once. How many times does 3 go into 21? 7. So now I have 1 times 2, which is 2, over 7 times 1, which is 7, which is equal to 2/7. Checks. All good. Now, what about this? This is what they call a two-step problem. Okay? So again, order of operations reverse. So I'm going to get rid of adding and subtracting first. So I have -10, so the opposite of that is +10, giving me 4x is equal to 2 plus 10, which is 12. Now I got to get rid of that 4, and it's attached by multiplication. The opposite of multiplication is division. So I'm going to divide by 4, divide by 4. Therefore, x is equal to 3. Now I need to check. So I'm going to do 4 times 3 minus 10. Is that equal to 2? Well, 4 times 3 is 12, minus 10, is that equal to 2? 2 is equal to 2. That checks. That's great. Here. Wow, this is a doozy. This looks scary. All right, the first thing I'm going to do is combine like terms. These two are similar. So I'm going to do 5z minus 3z. Well, that gives me 2z. All right. And these are similar terms. So I have negative 7 plus 5, giving me minus 2 is equal to 0. Now that equation doesn't look so bad. I'm going to get rid of the add, subtract first, then the multiply and divide. So now I'm left with 2z is equal to 2. I'm going to get rid of that 2 in front of the z by divide. So z is equal to 1. Now let's check this. And you go back to the very original equation to check. Don't go back to something along the way because you could have made a mistake along the way. Go back to the original equation. So is 5 times 1 minus 7 minus 3 times 1 plus 5 equal to 0? Well, that gives me 5 minus 7 minus 3 plus 5. And is that equal to 0? Well, what is 5 minus 7? That's negative 2. Minus 3 plus 5. You can do this all at one step. I'm just going to take it very slow. 2 minus 3 is negative 5 plus 5. Is that equal to 0? Oh, thank goodness, 0 is equal to 0. So back at this step, you can enter that into your calculator and do a really quick check and go, yes, that checks. I just went through it one step at a time to make sure that everybody knows what's going on. And you are welcome to do it however you want to do it. Okay, what about this problem? Okay, so here we go. I need to get x's all on one side. I'm going to keep my x's positive. So I'm going to subtract 5x. So that gives me negative 4 is equal to 20x plus 8. Now I need to get rid of that 8, so I'm going to subtract 8. That gives me negative 12 is equal to 20x. Now I need to get rid of that 20. I'm going to divide both sides by 20. And therefore, I'm going to get x is equal to negative 12 over 20. At this point, do not enter this into your calculator and give me a decimal answer. The computer is going to tell you error. You need to simplify this fraction. So, well, you got to ask yourself what goes into both of those. You are looking for the largest number that goes into both of them, but you may not see it. I do see 2's. How many times does 2 go into 12? Well, 6 times, so that'll become 6. How many times does 2 go into 20? 10. Okay, and then I've got negative 6/10, and I can see again, I can do that again, I can do 2's again. How many times does 2 go into 6? Negative 3 times. And how many times does 2 go into 10? 5 times. So my answer, x is equal to negative 3 fifths. Okay, now I need to check. So this is going to be, I'm going to put this into a fraction because I got a fraction answer. Times negative 3 over 5 minus 4. Is that equal to 25 over 1 times negative 3 over 5 plus 8. Okay, I'm going to start here back at the beginning. So those are going to cancel, giving you 1. So that's going to give you negative 3 over 1, or just, really, I would just write that as, you don't even have to write that as negative 3 over 1. You can just write that as negative 3 minus 4 is equal to, now let's check these crosses. 25 and 5 have 5 in common, okay? 5 goes into 5 one time, and 5 goes into 25 5 times. So now I've got 5 times negative 3, which gives me negative 15, all over 1, or just negative 15, plus 8. Negative 3 minus 4 is negative 7, which is equal. Is that equal to negative 15 plus 8, which also is negative 7? Yes, that checks. All right. Please email me if you have any questions or ask me questions in class. But that concludes section 2.2.